We often think of evolution as ancient history, but it's happening right now. On the Tibetan Plateau, evolution is visible in real time. In Nepal's highlands, women are adapting to low oxygen levels. Their bodies are evolving to enhance survival and reproduction. Researchers found a sweet spot in hemoglobin levels for success. It's not about perfection, but balance and adaptation. These women show evolution is ongoing, shaping us today. Their hearts and lungs are proof of human adaptation. Evolution isn't just history, it's a living, breathing process.
Welcome back to another deep dive.
Glad to be here.
Today we're looking at something really fascinating, how humans are changing, evolving right now, especially in some really extreme environments.
That's right. We're diving into human adaptation, specifically how people manage to thrive, not just survive, in places with really low oxygen. Think high altitudes.
Like the Himalayas.
Exactly. It gives us this incredible window into human resilience and biological variation.
And for this deep dive, we're drawing on some great sources provided by IDR. They give us a direct line to some pretty cutting-edge research.
And some of the findings might really surprise you.
Yeah, things that kind of flip what you might expect, like what trait is actually key for success high up. It's maybe not what you think.
And the fact that we can see natural selection measurably happening today, it's not just ancient history.
Definitely. It's vital, current science, super relevant if you're building your knowledge base, maybe even, digging into scientific developments for something like UPSC prep, where these biology environment links are important.
So let's set the scene. We're talking about the Tibetan Plateau.
Okay.
Humans have been living there for, over 10,000 years. And at incredible altitudes, often above 3,500 meters, that's, over 11,000 feet?
Wow. That high up, the air is thin. Really thin. I mean, I feel breathless just thinking about it. Tourists struggle, right?
Oh, absolutely. Basic tasks become difficult. And that intense, constant, low-oxygen environment, hypoxia, that's the term. That's the key. It's why the plateau is such a unique sort of living laboratory for evolution.
Because the pressure is severe and it's consistent.
Exactly. It affects everyone, and we can actually measure its impact. It's a clear driver for natural selection.
And our sources point to a specific, very recent study that gives us some fresh insights here.
Yes, a really important one. Published in PNAS, Proceedings of the National Academy of Sciences, just this year, 2024. It pulls together work from researchers like Cynthia Beale.
From Case Western Reserve University. I think I've seen her work mentioned before.
That's the one. She spent decades studying these populations. And she put it really well, saying high-altitude hypoxia is a beautiful example of how and why our species has so much biological variation.
Okay, so let's get into the first big finding, because this one, it sort of goes against common sense, doesn't it?
It really does.
My first thought is, thin air, you need more hemoglobin, right? More red blood cells to grab every possible bit of oxygen.
That's the logical assumption.
But that's not what this study found was most beneficial.
Not quite. And that's maybe the most striking part. They looked at health data, reproductive data, from 417 women living high up in Nepal.
Okay.
And the result was pretty clear. The women who had the most live births, which is our marker here for reproductive success, essentially evolutionary fitness.
Right. Who's passing on their genes most effectively?
Exactly. They weren't the ones with the highest hemoglobin levels, or the lowest, for that matter.
Somewhere in the middle.
Precisely. Intermediate hemoglobin levels were associated with the highest reproductive success.
Intermediate? Why? Why wouldn't you just max out your oxygen carrying capacity? That feels counterintuitive.
Well, there's a trade-off. Too much hemoglobin can actually cause problems. It makes your blood thicker, more viscous.
Ah, risk of clots, things like that.
Exactly. Increased risk of stroke, pulmonary hypertension, other complications. So while grabbing more oxygen sounds good, it comes at a cost if your blood gets too thick.
Okay, that makes sense.
So previously, the thinking was, very high hemoglobin is bad, and lower levels compared to sea level folks were seen as the adaptation. But this study really pinpoints the sweet spot.
So it refined that understanding.
Right. Beale actually said, previously we knew that lower hemoglobin was beneficial. Now we understand that an intermediate value has the highest benefit. It's finding that optimal balance.
Getting enough oxygen, but without the dangerous side effects of, sludge for blood.
You got it.
Huh.
But it wasn't just about the amount of hemoglobin.
Oh.
Would also look at how well that hemoglobin was actually doing its job binding oxygen.
Oxygen saturation.
Exactly. And they found that having higher oxygen saturation of that intermediate level of hemoglobin was increasingly beneficial. So the better your blood is at actually picking up oxygen in the lungs.
The better your reproductive success.
Correct. As Beal put it, the higher the saturation, the more beneficial. So it's like the Goldilocks amount of hemoglobin combined with maximum efficiency in using it.
Okay, this is fascinating. How does the body achieve that efficiency? Beyond just the blood chemistry, what else did they find in these women who were more successful reproductively?
This is where we see some really striking physiological adaptations come into play. It's not just the blood.
Right.
Women with higher reproductive success showed specific traits in their circulatory systems. For one, higher rates of pulmonary blood flow.
Meaning blood moves through the lungs faster.
Much faster, which maximizes the chance for hemoglobin to grab those scarce oxygen molecules as it passes through.
Okay, makes sense. More passes, more chances.
And they also found these women tended to have wider left ventricles in their hearts.
The left ventricle, that's the big chamber that pumps oxygenated blood out to the whole body, right?
That's the powerhouse. So think about it. You've got blood rushing through the lungs, efficiently picking up oxygen, and you've got a stronger, more effective pump, that wider ventricle, pushing that oxygenated blood out to the tissues.
So it's a whole system working together, these subtle physical differences in how the heart and lungs work.
Exactly. These traits act together as really powerful adaptations for getting oxygen where it needs to go when there's just less of it available in the air.
So natural selection isn't just picking one magic bullet trait, like the perfect hemoglobin number. It's more complex.
That's a really crucial takeaway. The study clearly showed selection favoring these various traits, but it's not like a simple checklist. One of the really unexpected things, Beal noted this, was that women could kind of compensate. She said, it was unexpected to find that women can have many live births with low values of some oxygen transport traits if they have favorable values of other oxygen transport traits.
Ah, okay. So maybe your hemoglobin level isn't perfectly intermediate, but you make up for it with, say, super efficient blood flow or that stronger heart pump.
Precisely. It seems to be about the overall harmony or the balance among all these different traits. Fitness isn't about being perfect in just one area. It's about how the whole system functions together effectively.
That makes evolution seem much more, I don't know, flexible or nuanced.
It is. Now, the sources also mentioned they look at social factors too, right? Because that always plays a role in human lives.
Good point. Like when people have children?
Yeah, they accounted for things like the age women started having children, how long their marriages lasted, things that obviously influence the total number of kids someone might have over their lifetime.
And did those factors explain the differences in birth rates?
They played a role, of course. But even after statistically accounting for those social and cultural influences,
the physical traits still mattered?
Absolutely. The physiological advantages, the intermediate hemoglobin, the higher saturation, the efficient circulation, they remain strongly linked to having more live births, independent of those other factors.
Wow. Okay.
And here's another really fascinating twist, maybe the most counterintuitive part.
Go on.
The physical traits that were most strongly associated with success, with having more children, in these high-altitude women, they actually tended to look more like the physiology you see in people living at low altitude.
Wait, hang on. The people best adapted to living way up high look more like people living down near sea level, physiologically speaking. That seems completely backward.
It does, doesn't it? It's a bit of a head-scratcher at first. But it suggests something profound about the direction of adaptation here.
What might that be?
Well, perhaps the most successful adaptation isn't developing some radically different, specialized high-altitude system. Maybe it's finding ways to effectively normalize oxygen delivery, to make the body function as close as possible to how it would optimally function at lower altitudes, despite the thin air.
So evolution is favoring traits that kind of bring things back towards the baseline rather than pushing them further away into some extreme adaptation.
That seems to be what this data suggests for this population. It really precisely.
Yeah.
And understanding these specifics, the intermediate hemoglobin, the circulatory efficiency, the way traits can compensate for each other in a real-world setting like the Tibetan Plateau, gives us this tangible grasp of how evolution actually works right now.
It's not just theory anymore.
It's observable science.
So why should you, listening to this, care about hemoglobin levels in Nepal?
Well, because this is such a clear, compelling example of humans adapting to their environment in real time.
Hmm.
It's directly relevant for understanding our own biology, how genes and environment interact, how populations change.
Hmm.
It touches on basic science, genetics, environmental science.
Fundamental stuff.
Right, and it's current affairs science, too.
Yeah.
Important findings happening now. So whether you're just curious, studying biology, or maybe even preparing for exams like the UPSC, where understanding this kind of current research is really valuable, this study is a perfect case study.
It really encapsulates ongoing human evolution in action. Okay, so let's quickly recap the key takeaways from this deep dive. Thriving at high altitude, it seems less about maximizing hemoglobin and more about hitting an intermediate sweet spot.
Right, paired with high oxygen saturation, making the most of the hemoglobin you have.
And success also comes from optimizing how oxygen gets around the body through things like faster pulmonary blood flow and those wider left ventricles in the heart.
Plus, natural selection isn't rigid. It favors a kind of harmony or balance, where strengths in one area can compensate for weaknesses in another.
And maybe most surprisingly, the traits that seem most beneficial high up can actually look a lot like standard lowland physiology.
Suggesting adaptation might sometimes mean finding ways to function normally under stress.
And the biggest point, we can actually observe and measure natural selection shaping human populations right now. It's living evidence.
Which leaves us with a final thought, something for you to maybe ponder.
Mm-hmm.
Beyond extreme altitude, what other environmental pressures, maybe much more subtle ones in our modern world, might be quietly shaping human biology today?
That's a great question.
And could they also be favoring traits that maybe counterintuitively look surprisingly typical rather than radically different? Where else might we be adapting in ways we don't even realize?
Definitely food for thought. A big thank you for joining us on this deep dive, exploring these fascinating sources provided by IDR.
Always a pleasure.
If you found this interesting, and we hope you did, please do like and subscribe to the deep dive wherever you listen. That way you won't miss our future explorations.
And we genuinely want to hear from you.
Yeah, absolutely. Drop your thoughts, your questions, anything this sparked for you in the comments section below. Let's keep this conversation going. Thanks for tuning in.